В Москву надо ехать тебе, в основное, куда писать, на себя посмотреть. Куда, ну вот на это. Вот нет. Вот такая вот так. Вот это есть. Ну да, хорошо. Да, извини, это понимаете. Вот это есть. Ну ладно, вот надо было. Это нормально. Ну да. Ну это и есть на самом деле.
Найдите работу на лучших условиях среди сотен тысяч вакансий на Авито. Например, рядом с домом. Авито. Здесь решают люди.
Notice anything interesting about this image? It actually contains itself, which is over here, hanging on the wall. Because it's the exact same as the original, it contains an even smaller version. And then that copy has an even smaller one, and that an even smaller one, all the way down forever. This is a visual example of recursion, which is when an object is defined in terms of itself. You can think of it as when something is made up of a smaller or simpler version of the original thing, which leads to repetition as you go deeper and deeper. Recursion can also be found in math, computer science, language, and maybe even, I don't know, video games? Okay, yeah, I have no idea how to turn this into a game. My first thought is that the player could be a smaller copy of the level, and you sort of navigate around inside yourself. So I got to work on this idea. The main challenge is to figure out how to make that infinite recursive effect. After a little research, I learned about render textures, which let you render a camera's output to a texture. And we can use them to easily create a larger or smaller copy of the entire scene. Next, I made a basic level and threw a character controller on the smaller copy of the level. And now we can get to the fun part, programming. What I did was write a script that orients the different render textures on the original player position and rotation, which as always worked on the first try. After a few bug fixes, here's what it looks like. So you control the character jumping around inside a larger version of itself. But that larger version is jumping around inside an even larger one. And inside our original character is an even smaller copy. And that goes all the way down. The problem, though, is that it's not fun. If we instead have a regular player character inside an infinitely recursive world, then we can explore the mind-bending concept of traveling between the different recursive instances. So now the challenge is to actually make an infinite amount of levels and players all interact with each other. Should be pretty easy. Alright, I somehow finally got it working. Now you can jump out of your main square-shaped room thing to become smaller, or enter the smaller version of the room to be relatively larger. And this can happen infinitely. For the 6 people actually interested, here's how it works. Basically, the set of platforms that make up the level are created 3 times. The player also has 2 scaled clones that track its exact position and rotation, but on their relative scales. If player, for example, enters the smaller copy, then the larger player clone is converted into the main player, and new clones are generated. Then for the even smaller and larger rooms, we'll just use a render texture, giving the illusion of infinite recursion in both directions. So now you can travel between levels forever, never able to escape. Fun. Also, if a recursive copy is rotated, then there's an effect on gravity. The player's gravity force stays relative to the original level it spawned in, which can have some mind-bending puzzle potential. And why not? We can also spawn multiple copies scaled and rotated in different ways. This might get just a little confusing, so we'll look at some examples later. But here's a preview.
On vous a peut-être dit que pour avoir des clients et faire marcher son business, il fallait absolument avoir un blog, écrire des articles tous les jours.
Now it's time to make this game, well, a game. Inspired by 2D golfing mechanics, you will aim and launch the player, and only have a limited number of moves to reach the goal. So I started by making this basic aim indicator thing, and programmed it to launch in that direction when you click. Next I made some sensor objects. Overlapping with one will light it up, and in order to pass the level, you have to light up all the green sensors and none of the red sensors. How about some UI? With all the game mechanics done, I can finally make some levels. I started by sketching out a lot of ideas. Now let's put them in the game. Here's what I've got so far. The game starts out with some easy levels that introduce you to the basics of launching and lighting up sensors. Ah, hold on. There we go. See? Easy. Then we've got a level that forces you to use the recursion mechanic. So jump down here, then into the outer level. In this level, you can't jump high enough to reach the green sensor. So what do? You guessed it, just enter the smaller room where you're now relatively larger and can make the jump. This one, yeah, I don't even know, you'll just have to play it, I guess. Here's the infinite staircase. Each step we jump down results in a larger and larger player we control. In order to reach all of the sensors, you have to jump down and balance on an infinite stack of copies of yourself. Next we'll introduce the gravity mechanic. The inner level is rotated 180 degrees, so every other player copy has reversed gravity. This one explores a 90-degree rotation. And finally, the double recursion level. You have 2 copies of the room inside itself, and 2 sensors you need to light up, but only 1 player. If you jump inside one of the rooms, you basically get scaled up, which isn't very helpful. But if you jump out of the level, a smaller copy of the player jumps out of both smaller levels. So now you can light up the 2 sensors. An algorithm is basically a series of steps to solve some problem. But what if one of those steps is to perform all the steps of the original algorithm itself? This is recursion in computer science. Here's an example. We'll start with a triangle. The first step is to remove a piece from the center, like this. And whoa, look at that. We now have 3 triangles. The next step is to apply the same overall process to each of them. So remove the center, 3 new triangles, apply the same process for each. Remove the center, 3 new triangles, apply the same process for each. Well, that took a while. The result is a fractal called the Sierpinski triangle, which was generated from a recursive algorithm. Alright, what is this? Math? Class? Let's get back to the game and work on the graphics. My original plan was to use Unity's 2D lights for this cool shadow effect, but they broke the illusion of the seamless transition between the different recursive level copies, so sadly they won't work. A little post-processing never fails though. I'll also make a Sierpinski carpet for the player sprite. This is a square-shaped fractal made out of 8 copies of itself. And finally I'll add some subtle drop shadows to each object, if I can do it without breaking everything. Okay, I've actually still got a lot to do. Title screen. Level select menu. Sound effects. More levels. Oh, well, that's not good. Yeah, I don't know. For some reason this game causes Unity to crash a lot. Not sure why. Alright, I think I'm starting to recover from those levels we looked at earlier. Let's see some more. I feel like it's maybe possible that this game is just slightly confusing, so I made a few easier levels to more gradually introduce mechanics like the initial recursion, gravity change, and double recursion. In this one, you need to somehow light up 5 sensors. Maybe that duplication thing will be useful. Here's a level with a very slight rotational and scale offset. Is it even possible? I don't know. See if you can beat it. Alright, how about 4 copies of the level inside itself? Watch what happens when you jump out the bottom. And the very last level might cause you some problems with producing infinitely many smaller and smaller copies of yourself. Alright, I guess the game is done. Link is in the description if you want to try it for yourself. Good luck, I guess. I decided to enter the Community Game Jam, where you have 1 week to make a game based on a theme. Let's see if I can actually finish something. At 3 o'clock on Saturday, the theme is revealed. The game is a liar. By the end of the day, I had a lot of ideas, but nothing seemed like it would actually make a fun game. Sunday, I still couldn't think of a good idea, so I decided to just start making something and then try to fit the theme in later. Let's start by making a basic character and a script to control it. Our character will be controlled by a wheel, so maybe he can be some kind of robot or something. Controlling the player only with a wheel made for some fun mechanics. You can't move right or left when in the air, so you have to build up some momentum on the ground first to jump onto new platforms. Speaking of platforms, I decided the game would be a platformer, but not just any platformer, a procedurally generated one with infinite levels. I made something similar with a friend in high school for a project, so maybe it would be fun to do an improved version of it. On Monday I had classes all day, so I mainly just thought about how the level generation would work. Here's what I came up with. First, place an initial platform. Then choose a random direction to build from. If we're going to the right, pick the top right corner of the existing platform as a starting point, and then possibly shift the X and Y position some. This is the starting point for the next randomly selected platform. Continue building like this for a random amount of times, performing some tests to make sure that there's no weird overlaps, and finally spawn an ending platform. Tuesday, I started writing the code to make this level generation system actually work. The 2 platforms in the game so far are regular static ground pieces, and some moving platforms that bounce between 2 points. The 2 platforms in the game so far are regular static ground pieces, and some moving platforms that bounce between 2 points. It's already Wednesday and I don't feel like I've made enough progress. Oh well, let's keep going and see what happens. The platform generation was still far from creating interesting or fun levels, so I spent some more time working on that. I at least needed to start making some game art, so I designed a little robot character and opened up Illustrator to bring him to life. Now let's rig him up in Unity. To finish off Wednesday, I worked a little bit more on the graphics. Thursday, I made a a parallax script so the background can be a little more interesting. I also worked on the logic for moving between levels. An ending platform will contain a transmitter, which will send the robot's data to some other location into another robot body. Also, each level can have multiple ending platforms, creating a huge tree of levels you can explore. Each level is generated from a starting seed, which means that even though the platforms are randomly generated, everyone that plays the game will get the same levels. The game is due tomorrow, and it doesn't seem close to being finished. I started the day by adding a camera fade effect between levels, and created an image for the transmitter. Now when you die, you'll break into pieces and inhabit the body of a new robot that spawns at the beginning of the level. For some reason, even though at this point I have less than 20 hours to submit, I start playing around with normal maps and post-processing effects. Let's get back on track with a little animation. I want the robot's face to be a small digital screen, so I opened up After Effects and created some eye animations where each frame is just different squares lit up on a grid. It's Saturday. I still need a name for the game, a title screen, a tutorial level, music, sound effects, and definitely some more platform types. I decided to call the game Where's Bill? The robot character is looking for his friend Bill, and the lie to fit the theme is that Bill isn't actually in the game. Kind of a stretch, but oh well. I've never made a song in my life, so let's see how fast I can learn. I remember a Brackeys video about this program, so I'll try to figure it out. Alright, I have no idea what I'm doing, just putting random notes and listening to how it sounds. Made a new platform, Spinner. It can be an obstacle to avoid, or it can launch you up onto higher platforms. Alright, 2 hours left. I think I can add one more platform. This is just one that if you touch, you die. Yeah, my creativity is totally gone at this point. Alright, I think I'm done. I just need to find a starting seed that will generate some good starting levels. Build, test, upload, submit.
Hi everyone, and welcome to a new episode of Coding Adventures. Today we're going to be exploring the game of chess. Let's begin simply by creating the chessboard. So we'll need two loops for the x and y axes, or files and ranks if you prefer. And to tell if a square should be colored light or dark, we can just check whether or not the file plus the rank is divisible by 2. Let's try running this code, and here we have our very humble beginnings. I expect I'll be staring at these 64 squares a lot in the coming days or weeks, depending on how challenging this turns out to be. So I'll tweak these colors to something a little easier on the eyes. Next we'll need some pieces, and I found this nice design online, which came along with some interesting additional ideas for a giraffe, a zebra, whatever this is, and several more. I think chess is confusing enough as it is though, so I'll stick to these for now. We then need to represent these pieces in code, so I'll assign each type of piece a number, along with a number for white and black. These values could be pretty much anything, but I chose these particular ones so that if we look at a piece in binary, the 3 bits on the right will tell us what type of piece it is, and then the 2 bits on the left tell us if it has a color associated with it, which can be white or black. So let's now create an array of 64 numbers, which will be the computer's internal representation of the chessboard. These are all 0 by default, but we could place, for example, on square 0, a white bishop, and on square 63, a black queen, and whatever else we want. Behind the scenes, I also added some code for actually displaying the pieces. I'm not sure if they're obscuring quite enough of the board at the moment, though, so let me fix that. Perfect. Now, instead of setting up the board piece by piece in that array, I'd like to support the standard notation called fen. Here's an example of a fen string, which might look terribly cryptic at first glance, but it's actually really simple. We start at the top left square, and here we have 7 empty spaces, followed by a lowercase k, meaning there's a black king hiding in this one. We then go to the next rank and skip 3 spaces, and here we have an uppercase n, meaning a white knight. You're probably getting the idea already, so I'll spare you the tedium of going through the rest. I've written up this little function to translate those fen strings to the format we're using, and up at the top here, I'll write out the fen for the starting position, so we can load that in. And here it is. I've also implemented some simple drag and drop behavior for the pieces, although it's not quite behaving how I'd hoped. I'll go ahead and fix that quickly. So now, it's making the pieces disappear for some reason. I'm rapidly losing faith in my ability to code anything, but I have at last got it working, and I think it's looking nice. Although, of course, nothing's really stopping me from sneaking in a move like this, when my opponent's not paying attention. So the first real challenge of this project is going to be calculating what the legal moves are in any given position. So, these are the indices of our squares, and from any square we can move orthogonally like a rook.
Жена, да, говорит,